In this lesson, I'll introduce you to a method of creating threads. Here we have a plastic bottle, and we'll be adding an external thread to go along the mouth. Modeling threads in SOLIDWORKS is a three-step process. First, you have to create a helix that defines the thread pitch. Second, you must define the thread profile. Third, you must terminate the thread to eliminate the abrupt ends. Let's begin by creating the helix for a sample thread. The helix will be based on a circular sketch. Often the dimension from the top of the bottle to the top of the thread is important. Because of this, rather than sketching a circle on the top face of the bottle, I'll create a plane offset from the top surface. Next, I'll begin a sketch on the newly created plane, and I'll convert the top edge of the bottle to generate a circle. With the circle in place, I can launch the helix feature from the Insert, Curve drop-down menu. The helix will be defined by pitch and revolution. I'll specify a constant pitch and a number of revolutions starting at 0 degrees. Then click OK. Now that the threads path is created, I'll move on to creating the thread profile. This will be the cross-sectional shape of the thread itself. I'll create a new plane that is normal to the end of the helix. This will provide the correct orientation for the cross-section. And I'll sketch the thread profile on the new plane. Sketching the thread profile is the most time-consuming step in creating a thread. Since thread profiles are likely to be reused, consider saving them to your design library for quick access. You'll want to make sure the sketch for the thread profile is fully defined. That way you can be sure the resulting thread geometry is exactly what you're looking for. I'll continue adding dimensions and relations to fully define the sketch. Note the overlap of the thread profile into the body of the bottle. This is important. Without the overlap, the contact area between the thread profile and the bottle could result in zero thickness geometry, generating an error. With the thread profile complete, I'll exit the sketch and create a sweep feature. The sweep profile will be the thread profile sketch, and the path will be the helix. I'll click OK, and the thread is nearly complete. It's important to notice that to create this external thread, we're simply adding a sweep feature. The same process can be used to create an internal thread, but by instead applying a swept cut to remove material. At this point, all that remains is to terminate the ends of the thread. There are several techniques for doing this. One of the more common approaches is to use a revolve feature. I'll begin a sketch on the starting face of the thread. The profile I'll be revolving is the shape of the thread itself. Using the Convert Entities tool is a quick way to capture the shape. However, note that converting the face itself can cause a problem. The lower edge of the profile is not linear, so it can't be used as an axis of revolution. I'll use Convert Entities with the original sketch selected from the Feature Manager tree. This gives me the profile I need. I'll launch the Revolve feature, and I'll use the lower edge as the axis of revolution. If you want to have a more gradual termination, you can always increase the radius of the revolve. You can do this by adding a center line at a distance from the profile sketch. The revolve only needs to go 100 degrees to merge into the body of the bottle. You can see this in a top view. If you want to make sure the revolved feature completely merges with the bottle, extend it well beyond the bottle surface. Then as a second step, you can cut away any material that protrudes on the inside. This completes one end of the thread. The other end is a bit more complicated because we don't have the original sketch available for use as a reference. There are several ways to overcome this. The approach I'll use is to simply reuse the sketch from the other end of the thread. I'll do this using the little-known derived sketch command. I'll select the end face of the thread along with the sketch used previously for the revolve. I'll then click Derived Sketch from the Insert drop-down menu. To position the sketch properly, I'll add a couple of geometric relations. And the sketch is complete. Note that this derived sketch is controlled entirely by the original sketch. Once it's in position, it is fully defined without the need for dimensions. I'll create another revolve to complete the thread. And there you go. We get exactly what we were looking for.